Students, today's agenda is to check homework. We'll be learning about mixed polynomials and you will be able to do 2.7. Today, students will be able to factor different types of polynomials. And what I decided to do is to put the name or how we can factor that polynomial and then an example of it. And I think that's going to make it a lot easier when you have to look at the different polynomials. So in here, this says the greatest common factor. And the reason is because you can see that a number can go into all the coefficients and also that you have variables on all of them. Sometimes the greatest common factor is just for the numeric part. But if you have x in all the terms, then that forms part of the greatest common factor. And so let's look for that greatest common factor. For these three terms, we can see that 2 goes into all of them, so it will be 2. And then for x, you always get the one with the smallest exponent. If there is no exponent, that means that there is a chiquitito, which means the tiniest, right? And so it would be x to the first power. After that, you just open your parentheses and start dividing. 2x cubed divided by 2x, that will be x squared. Negative divided by positive is negative. 8x squared divided by 2x, that will be 4x. And then in here, 4x divided by 2x, that will be 2. And the reason because the x cancels is because x divided by x is just 1. Since there is no number that multiply equals 2 and added equals -4, that's all we are going to do. Those will be my two factors, a monomial and a trinomial. For the next one, we have difference of squares. This is a perfect square. This is a perfect square with minus in the middle. Difference means subtraction. And when you have this, all you have to do is open two parentheses. You take the square root of x squared, and it's x, and put it in both parentheses. And then take the square root of 144, and that's going to be 12. Put it in both parentheses. And so that you don't have the middle term, you need one positive and one negative. And those will be your two factors. And so difference of square is one of those special squares, and also the perfect square trinomial. That's the next one. That's with the formula a squared plus 2ab plus b squared. And what that means that when you have a perfect square in here, a perfect square in here, and this is double, meaning that if you divide this by 2, then you have a perfect square. And I think I'll show you with this one how to do it, but then at the same time I'm going to do the drawing so that you can see. So what you need to do when you see that this is a perfect square and this is a perfect square, what you have to check really fast is divide this by 2, and then if you take the square root of this and you get the same answer, then that's what you have to do. Your factors will be x, take the square root of that is 4, divide that by 2 and it's also 4, and you have to use this sign, the sign of the middle term. Okay, so in here I put plus or minus, because if this was negative, you use the negative, but since it's positive, you just put positive, and that's going to be squared. Again, how do we know that it's a perfect square trinomial? Is by looking at the first and last term. If they are perfect squares, and then this divided by 2 and the square root of this gives you the same answer, then that's what you use in there with this sign. Okay, now let me draw it, and it's called perfect square because you know that squares have the same dimensions for all 4 sides, right? But to get the area, you will always multiply the length and the width. And so in here, this will be the length, so it's x plus 4. This, because it's a square, has to be the same, x plus 4. What do we get for this area? X times x is x squared. 4 times x is 4x. 4 times x is 4x. And this one is 4 times 4, which is 16. These two, which refers to these two, are the 8x. Okay, that's why you always multiply 2 times a times b. 2, this times this. This is a and this is b. The next one is the diamond method. That's the one where we use a diamond on the side. And we put the last term, the constant on the top, and we're looking for two numbers that multiply equals that number. But that when you add those, you will get the middle coefficient. And so what are two numbers that multiply equals 2, but when you add them equals 3? Well, it's 1 times 2 equals 2. 1 plus 2 equals 3. And as we saw in previous lessons of this unit, you have to also consider the signs in here, but you can look, I'm going to link at the end the entire unit around here so that you can look at those videos. But yeah, you have to pay attention to the sign. But for this one specifically, you just open your two parentheses, you put x, and then use your two factors. So plus 1, plus 2. For the next one, it says when a is not 1, a, remember this part, a, b, and c. So when a is not equal to 1, we have to use grouping. And so it's in combination with the diamond, and you multiply a times c to get the numbers that multiply equals that number. So 2 times negative 10 is negative 20, and the middle term's the same. Now we're looking for two factors that multiply equals negative 20, but when subtracted, this tells me that I'm going to subtract, is going to be 1. Well, what two factors of 20 are one space difference? So it's 4 times 5. Now, to make a negative, one of them has to be negative, and the biggest one has this sign. Since it's positive, that means that the negative will be with the smallest one. And we don't open our parentheses right now. Now is the moment to use grouping. What do we do instead? The first term stays the same. The last term stays the same, but the middle term is replaced by these two factors. And so negative 4x, now we include the x, and positive 5x. You can see that negative 4x and positive 5x is your x right there. It's just being replaced, and it's not changing anything in the polynomial. The next step is to do grouping. We're going to be finding the greatest common factor for each of those two groups. So the greatest common factor for 2 and 4 is 2. For x squared and x is x. Remember, is the biggest number that can go into both, but the variable with the smallest exponent. And then we start dividing. 2x squared divided by 2x is x. Negative divided by positive is negative. 4x divided by 2x is 2. Why didn't I include the x? Because x divided by x is 1, and we don't need, so it means it cancels. What goes into both 5x and negative 10? That will be 5. Divide 5x divided by 5 is x. Negative 10 divided by 5 is negative 2. And something super important in grouping is that these two have to be exactly the same. So we put it only once, x minus 2. The other two numbers, the ones that are the greatest common factors, we put them together. So 2x plus 5. If there is no sign in here, that means that it's positive. And so those will be your two factors. And how can we check? 2x times x is 2x squared. 5 times negative 2 is negative 10. And then the happy face, make the nose. 5 times x is 5x. And 2x times negative 2 is negative 4x. And together, that makes the x. Because 5x minus 4x, x. That's the middle term. Again, if you need to see more of these examples, look at the playlist that is going to appear at the end of the video, and you can start looking at more examples for each one, okay? If you go to lower levels of math, then we can say that this cannot be factored. X squared plus 25, even though these are two perfect squares, but you have a plus, they cannot be simplified. They cannot be factored. However, in Math 3, we can see that this can go on to complex factors. That we learned that in unit 1, and we do this by rewriting as when it's positive, it can be as negative times negative becomes positive, right? Of 25. So we're subtracting a negative 25. And then we just open our parentheses. We put XX. This minus makes it a plus and a minus. And then we take the square root of this one, and the square root of negative 25, well, the square root of negative is the imaginary, the square root of 25 is 5, so we put it as plus minus 5i. But if you're in lower levels of math, you might find this as prime polynomial, okay? It's a prime polynomial, meaning that there is no other factors, you cannot factor it anymore. And that's what it is. For prime polynomial, it just means you cannot factor it. And later on, that means that when you solve, when it equals to 0, you'll find imaginary answers. That's what it means for prime polynomials. Or the same for complex. Or the same for complex factors. Okay? So in here, you are just going to write prime polynomial. Okay, so now let's start with some practice. Those were just defining them. And this is going to be a very lengthy video, and the reason is because I'm going to give you a lot of examples so that you can really see. And so I wrote down the ones that we just defined right now. Two of the special squares in here refer to the difference of squares and the perfect square, and here we put the complex prime on one line. And so for number 1, no, it's not the greatest common factor. It's not a special square because this is not a perfect square. And I want to try the diamond. So negative 20 over here. 1 is over here. And two numbers that multiply equals negative 20, but added or subtracted actually is 1. So it will be 5 times 4. And this is the greater, so... And it's very similar to the one that we did for grouping. In this case, we're not multiplying A times C, so all you have to do is open your parentheses, put XX, and plus 5 minus 4. Those will be your two factors. Okay. For the next one, this is a perfect square, this is a perfect square, and a difference in the middle. So it's one of those special squares. Is the difference of squares. So all you have to do is open the two parentheses, take the square root of the first one and the square root of the last one, and you get the square root of 4 is 2, the square root of x squared is x, square root of the second one is 5. And remember, you have to have one positive and one negative. Why? Because that will, the happy face will eliminate the middle term. That's why you don't have the nose or middle term. For number 3, I can see immediately that these have a factor in common, and the biggest number that can go into 2, 4, and 2 is 2. I look to see if all the terms have A, yes, and the smallest one is the chiquitito. I see if all of them have B, yes, and all of them is just to the first power. So those are part of your greatest common factor. Okay, so we're using immediately the first one. And so we start dividing. 2 divided by 2 is 1. We don't need to put it. A cubed divided by A is A squared. Then B divided by B cancels. 4 divided by 2 is 2. And since both are positive, you just put the plus in the middle. A squared divided by A is A. B divided by B cancels. It's 1. Positive divided by positive is positive. 2 divided by 2 is 1. We don't put it. A divided by A is 1. We don't put it. And B divided by B is 1. So we usually don't put it because we expect to get something else. But since all of them are 1, 1, 1, 1, so it's 1 times 1, 1 times 1, 1. So that's what we're going to put in here. Or we can just think of anything divided by itself. The answer is 1. The next thing that you need to do is see if whatever you got after dividing by the greatest common factor, if this can be factored even more. And this is a perfect square. This is a perfect square, and some people don't know it. And if we divide 2 by 2 and take the square root of 1, 2 divided by 2 is 1, and the square root of 1 is 1 also. So that's, again, the special square is the perfect square. And so this one we just bring down. But in here, the perfect square, it just means take the square root of the first part, which is a. Square root of 1 is 1. The middle sign is positive, and you put a square in here. So those are your 3 factors now. You have a plus 1 times a plus 1, and also times 2ab. Those are 3 factors. For the next one, you can see that it doesn't have a greatest common factor, but this is a perfect square, this is a perfect square, and we just have to see if this is the same. If we divide this by 2 and take the square root of that, do we get the same answer? 10 divided by 2 is 5. 25, the square root of 25 is 5, so yes, it's a perfect square. And so you immediately do that, put the x in here, divide this by 2, and that's what we get. Negative 10 divided by 2 is negative 5. Remember that we keep the sign of the middle term when we have perfect squares. And that's all. As promised, many more examples. And here I noticed that 8 and 32 have a greatest common factor, which is 8. And for the variable, nothing else, so that's all. 8x squared divided by 8 is x squared. Negative 32 divided by 8 is negative 4. And we would think that that's all we have to do, but guess what? This inside here has 2 factors. This is a special square, is a difference of squares. This is a perfect square and a perfect square. So we bring our GCF, or greatest common factor. We open the 2 parentheses. The square root of x squared is x, and we put it in both. Remember that this means that I'm going to have 1 positive, 1 negative, and the square root of 4 is 2. So those will be my 3 factors. So in here we were using greatest common factor and one of the 2 special squares. For number 6, I also see that all of them have a greatest common factor, which is 50. And for the x, this one doesn't have x, so I cannot put it in my greatest common factor. So I just start dividing. 50x squared divided by 50 is x squared. Negative 150x divided by 50 is negative 3x. And 100 divided by 50 is positive 2. And then we can check to see if this trinomial has more factors, and you can do it directly in here, finding the 2 factors that added equals this coefficient, or you can use the diamond. And you put positive 2 and negative 3. When you have a positive in here, that means that both of them will have this sign. Okay, so the only 2 factors of 2 is 1 times 2, or negative 1 times negative 2. Since this is negative, that means that both are negative, and negative 1 times negative 2 is, and negative 1 times negative 2 is positive 2, but when you add them, negative 1 plus negative 2 is negative 3, so those will be my 2 factors. Okay, whichever you prefer, you can do the diamond or just directly in here. And so you bring your GCF, or greatest common factor. We put, well, let's open both parentheses, x minus 1, x minus 2. And this can be switched as long as you keep always the same sign that belongs to them, okay? So those are my 3 factors. And again, you're using the greatest common factor and the diamond. So you're combining 2 of those. Okay, let's keep going here. This is a little different. It has x to the 4th minus 36. This is a perfect square, actually. And you get the square root of x to the 4th is x squared. And you put it once in here and once in here. This minus gives me a plus and a minus. And the square root of 36 is 6. But let me show you a different case. Let me write an extra one in here. If we had x to the 4th minus 16, what you would do is the same thing. We take the square root of the first and last terms. We put x squared x squared. And then plus minus, because it's a special difference, right? Special square. And then the square root of 16 is 4 and 4. And I noticed that, again, this is a perfect square for both of them. So that means that I can factor each one. And this will have the prime, if you want to leave it as prime, or you can have the complex solutions. So the square root of that one, but remember we have that extra step where we put minus -4. We put x in here and x in here. Because of this minus, we put 1 plus 1 minus. We take the square root of -4 and we get two imaginary number. And for this, it's a difference of squares. Again, we open the two parentheses, and I'm just going to use a different color. The square root of x squared is x. That minus gives me 1 positive, 1 negative. And then the square root of 4 is 2 and 2. So this ends up being 4 factors. 2 complex factors and 2 real factors. Okay, so that was just extra, but sometimes you will encounter cases like this. So for this one, I noticed that a is greater than 1, but I don't have a greatest common factor. So I'm going to go to a is not equal to 1 and grouping. So a times c, 48 times -5, well, it's going to be negative. 5 times 8 is 40, carry 4. 5 times 4 is 20, and 4, 24. So negative 240. And we're going to have to subtract the numbers, but the biggest one, the factors. And we're going to, when we find the factors, one is going to be positive and one is going to be negative. We have to subtract them, but the biggest one will be positive because 8 is positive. Now, if you recall, when we did this, we would find the factors of 240. And so you can do 2, then by 3, etc., etc. And we'll do that because I know that some people, they cannot easily just find that. And the more you get familiarized with factors and multiples, that's going to go easier. But if you are barely starting and cannot memorize your multiplication facts, that's fine. You can do this, okay? So 2, that means that you're dividing this by 2, and so 2 times 120, and the biggest one will be negative. 3, can this be divided by 3? 2 plus 4 is 6, so yes, 6 is divided by 3, and it will be, how many times is the 3 going into 24? It's 8, and just bring down the 0. Or you can use your calculator. 240 divided by 3 and put the two factors and see if subtracted they equals 8. 4, yes, because we were able to divide by 2 and this is even. So we just divide that by 2 and 4 times 60. By 5, definitely it ends in 0. So 5 goes into 24 4 times, and 4 times 5 is 20. You have 4 left. 5 goes into 40 8 times, and subtracted, you still don't get 8. Can you divide by 6? Yes, because you have the 2 and the 3 in here. So 6 in 24 goes, and you know this is going to be bigger. So 6 in 24 goes 4 times, and you just bring down the 0. Subtracted is not 8. 8, if it was divisible by 4, then, and it's even, that means that it's divisible by 8. So 8 and 30. By 10, yes, because it has a 0. So 10 and negative 24, and we still don't have 8 when we subtract it. 11, no, it's not divisible by 11. 12, how many times does the 12 go into 24? 2 times, but it's negative in here. And just bring down the 0. Again, use your calculator if you're not sure. But now I notice that when I subtract 20 minus, or when I have 12 minus 20 is negative 8. But I need a positive 8. So all I need to do in reality is just put the 20 in here and the negative 12. Again, because when I subtract these two, I got -8. By switching the sign to the 12, that's going to give me +8. And so those are my two factors. So it's 20 and -12. When I multiply 20 times -12 is -240, but when I subtract them is +8. And so in here, we don't just open our parentheses. Remember that we have to use grouping. This is substituted by these two factors, so plus 20x minus 12x, and bring down the last term. We group them and find the greatest common factor of each group. So what goes into both 20 and 48? The biggest number is 4, and for the variable it's going to be x. We open our parentheses. 48 divided by 4 is 12. X squared divided by x is x. 20 divided by 4 is 5, and x divided by x is 1, so that cancels. In here, the greatest common factor is -1, and start dividing. -12x divided by -1 is 12x. -5 divided by -1 is +5. And again, remember that these two have to look exactly the same. So 12x plus 5, 12x plus 5, and we just write it once. And the greatest common factor from each one, we write it in as the other factor. And so those are our two factors. I think of all of them, this is the lengthiest one of all, but there you have it. I noticed that I don't have the greatest common factor, and a is greater than 1, so you can check to see if there is grouping. And I'll start, but 5 times -1 is -5, and you're looking for two numbers that multiply equals -5, but when you add them equals +9, or actually when you subtract them. There are no two factors that multiply equals -5, because it would be only +5 and -1, but then they don't add to 9. So when that's the case, when you cannot use grouping or any of the other ones, you just say that that's a prime polynomial. Okay. Number 10. Oh, it's one of those special squares, because yes, 1 is a perfect square. Some people think that it's not a perfect square. Perfect squares is any number that you multiply it by itself, and that's the answer right there. Okay, those are the perfect squares. And so in here, we just open the parentheses. The square root of y to the 4th is y squared. Then because of the minus, we put plus minus. The square root of 1 is 1. And we put it in both. Again, you have one of those cases where I'm going to factor this one again, and we end up with two prime factors. So it's going to be, remember, y squared minus 1 is the same thing as y squared plus 1, because negative times negative becomes positive. We take the square root of y squared, and it's y. Because of this minus, you have 1 positive, 1 negative. The square root of -1 is 1i and 1i. Now I'm going to square this special square, is the difference of squares, and you also get two factors. The square root of y squared is y. Because of the minus, you have 1 plus 1 minus. Square root of 1 is 1, and so those are your two factors. I did not know I had this, so I created the other one extra for you. So I apologize for the lengthy video, but you have plenty of examples. This is the end of the lesson. If you can please give us a thumbs up, subscribe around here. This is the list for the entire unit, and here you will find the next video. Now you're able to do 2.7 and have fun.